Welcome to episode 12 of the 6 Lessons podcast. Today we're going to be talking about a topic near and dear to my heart, resin coating. Resin coating is a concept that doesn't get as much respect as it should. In the world of adhesive dentistry, all of the products that we use are resin-based. A resin idea is a polymerizable molecule. Resins can be very stiff, or they can be very flexible. For example, soft contact lenses, that has a monomer called HEMA, and HEMA is a water-loving molecule. It's very small, so it's very flexible, but it also adapts well with water. Now, harder plastics like these lenses of my glasses, they have a polymerization that is much more complex, and it does not like water at all, so that's a hydrophobic situation. In the composites that we use, the resins have a combination of hydrophilic and hydrophobic in the dental bonding systems. And the dental bonding systems have to connect to hydrophobic resins that are in what we would call the restorative composite aspect. But in between the dental bonding system and the restorative materials that we use, which are composites, we need to understand that there has been a tremendous amount of experimentation, and that experimentation has been both in the bonding systems and in the composite systems. There was a great breakthrough from Japan, and that breakthrough in Japan happened in 1989. It was brought to market in 1992. In the United States, and that was the introduction of a composite that was somewhere in between an adhesive of the dental bonding systems and the restorative filled composites, and that's called the flowable composite. Flowable composites had a viscosity that was very easy to spread around. There was no problem with it flowing, and that's why it's called flowable composite. But the filler of the flowable composite, to make it more stiff, we had a lot of options. The option that the first flowable composite, which came out of Japan, to make it stiffer was to take a composite that was polymerized and grind it up. And when it ground up into small particles and was put in the adhesive resin, then the polymerization was less because the matrix that was polymerizing was surrounding these filler particles. And so the shrinkage was reduced in half. It went from 7 and 8% to 3 and 4%. That was the first innovation. But this microfilled flowable with those ground up resin particles had more flexibility. It had a downside. It didn't have any radiopacity. It was completely radiolucent. So the first flowable, it was called Protect Liner F, which was part of the Liner Bond 1 system that was introduced in 1989 in Japan and 1992 in the United States, was able to be investigated in 1993 by Bart van Meerbeek, who we referred to last podcast, when he reviewed 30 different bonding systems that were available. Of those 30 bonding systems, less than a half dozen, maybe 4 or 5, are still marketed in the world. So 25 have not been manufactured now because they weren't as popular. They didn't work as well. But Van Meerbeek, when he used this Liner Bond 1 system in his PhD dissertation, saw that it did something very important when it added this layer of filled adhesive, a microfilled filled adhesive on top of the primer and bond that was part of the dental bonding system, photo bond, that was in the Liner Bond 1 system. And he found out that this had a characteristic which he called a gradient of MOE, modulus of elasticity, which is a measure of stiffness of a plastic. Some plastics flexible, some very stiff, but this modulus of elasticity gradient was a continuation of the gradient that he discovered in the 3 layers of the hybrid layer, which he called interdiffusionary zones. The lowest interdiffusionary zone, which is the most important, was that gooey encapsulation of water and hemomolecules, and that had a very low modulus of elasticity of around 2 or 3 gigapascals is the measurement of the modulus of elasticity. Sometimes it's called Young's modulus. But as the layers of the hybrid layer were investigated with a testing technique, which is called a micro-indentation technique. Van Meerbeek was able to see it went from 2 to 3 in the lowest interdiffusionary zone to 3 to 4 in the middle interdiffusionary zone, and then it got up to a stiffness of about 6 in the outer portion of the interdiffusionary zone. And then when the flowable was put on top of it, that brought that up to about 8 or 9 gigapascals. And so we had this gradient of stiffness, and that gradient of stiffness gave the characteristics of this liner bond system some superiority. At that same time, in the early 1990s, experimentations were done in the neighboring country of Belgium. Belgium is where Van Meerbeek was, but the neighboring country of Holland, in Amsterdam, experimentations were done by Carol Davidson, continuing his work of the 1984-87 period. And he had a graduate student that was very bright. Her name was Chantal Kemp-Sholte, and she published a very important paper in 1990. And that paper in 1990 started to test different types of liners that were being suggested to overcome this problem of sensitivity after restoration with composite fillings. Now, the composite filling sensitivity was a manifestation of shrinkage that pulled the hybrid layer and destroyed the hybrid layer, allowing a gap of pulpal fluid to be underneath the restoration. When the patient was biting on that, then all of a sudden the fluid went back out of the gap into the pulp, and that hurt. That's the hydrodynamic source of pain that Martin Brandstrom pioneered 10 years earlier in 1982. So Schulte was trying to solve the problem of sensitivity under restorations, composite restorations that had this shrinkage. So she's tried different liners, and the only liners that worked were composite-based, resin-based liners. The glass ionomer that had been introduced in that same decade had different characteristics, but it did not help with this bondability, and it didn't help with the sensitivity problem. But this idea that the seal was improved by using a resin liner, 1990, confirmed in 1993 by Van Meerbeek out of 2 different universities doing good dental research, in vitro dental research. When I read that paper, this would have been in 1995, 96 period. In my mind, I was starting to think in the terms of how long it takes to do something and how that affected the development of the hybrid layer. And this resin coating took a little bit longer to do, and that was the insight that I believe was the important part of the Kemp-Sholte paper, although it wasn't discussed in those terms. But this is the paper, and as you go through early papers, there's always questions of, well, why didn't they try this material? Why didn't they try this technique? But the answer is they're trying to figure out, and usually they're trying to simplify something. So when they introduce a step that takes more time, they're thinking, well, it's kind of a trade-off. You know, I'm going to get less sensitivity. It's going to take more time. But nobody was really thinking in terms of long-term success of mimicking a tooth. So the idea of biomimetic in its infancy really wasn't talked in terms of let's try to get a seal as close to a natural tooth as possible. But when I read this paper, there was another paper that had influenced me from the very beginning by my second mentor, and that paper was published in 1999, and this paper had the title Flowable Resin Composites as Filled Adhesives, written by Gary Unterbrink and Bill Liebenberg. Now, if you understand what that title is saying, you have to understand something about adhesives. You have to understand that the first adhesive systems bonding to dentin had no filler material, and they were not being used with a flowable composite, which can have different types of filled characteristics, microfilled, or later the ceramic filled, microfilled composites were basically replaced by the ceramic filled composites, which were called microhybrid filler flowables. But my second mentor after Ray Bertolotti was Gary Unterbrink. I didn't meet him until 1998 at the ADA convention in San Francisco, and when I talked to him for actually a couple hours, it was obvious that Ray Bertolotti's connection with Gary Unterbrink was very important. They were basically talking the same terminology on dental bonding systems, the same terminology on flowable composites, the same terminology on C-factor, which is a new concept to me, but I was asking him very specifically about how C-factor relates to shrinkage how shrinkage relates to bond strength, how bond strength relates to sensitivity or gaps underneath restorations. And these mentoring conversations that I had with Gary in 1998, later in 2000, 2002, 2004, Ray Bertolotti would bring Gary Unterbrink out to Lake Tahoe to give a lecture every couple of years. When he retired, I asked permission if I could use his PowerPoint, and he said, sure. So I got a copy of Gary Unterbrink's PowerPoint to take me deeper into the things that he understood. And this paper, for me, I call it a heuristic paper. Heuristic is a scientific term when you study something. It doesn't give you the exact answer of your question, but it teaches you some methods to think about how you might get to an answer of the actual question that a scientist is using. And so heuristic methods are methods that help you be a better investigator. I read this paper that was published in 1999 in a pre-publication form. So before you write a paper, there are many drafts. The paper that I'm best known for is the paper I wrote with Pascal Magni. I spent 4 months full-time writing the paper. The numerous drafts that Pascal and I would give to each other eventually led to the drafts that went to the Quintessence International, and then we had an editor there that would try to see if there were grammatical errors or logical errors that seemed questionable to somebody who wasn't familiar with the subject. Anyway, these editings can go through 5 or 6, 10 edits, but I did get this last pre-publication edit from Gary Unterbrink in 1998. And so when I read the paper in 1999, I already was very excited about it. But the first paragraph that he wrote said this: adhesive dentistry could be expressed as a simple relationship between bonds and stress. If the bonds can withstand the stress, the restorative technique will be successful. So I later, when I started to teach in 2003, these concepts of increasing bond strengths and decreasing stresses to make a restoration successful, I named this paragraph, I called it the adhesive equation. I coined that term, the adhesive equation. And by that time, in 2003, I had listed 8 different ways to increase bond strengths and 10 different ways to decrease stresses. Decreasing of stressing has to do with lesson 4 and lesson 6. Lesson 4 is decreasing polymerization stresses in the first 24 hours of the restorative period. And then lesson 6 is decreasing stresses for the rest of the life as the restoration is chewed on, and that's occlusion. And so lesson 2, lesson 4, lesson 6, those are all decreasing stresses. Lesson 1, lesson 3, lesson 5 are all increasing bond strengths. And the culmination of all of my investigations eventually brought me to the point that had been really ignored and overlooked, slightly mentioned a few times by Carol Davidson. It was that whenever we have these restorations polymerizing, we have to realize that there's a beginning to the polymerization and there's an ending to the polymerization. And so that eventually led me to the concept that I published, decoupling with time. And so between Carol Davidson, Kemp-Sholte, and Gary Unterbrink, the idea of decoupling and decoupling with time became the controlling concept that all of the 6 lessons teach protocols to improve bonds or decrease stresses. And so the main problem that was needing to be overcome with the decoupling of time was the hierarchy of bondability, or the differences in mineralization in each of the hard tissues. And I was able to identify 6 different hard tissues, and the scientific literature had been able to tell us how bond strengths could be achieved on these 6 different levels of mineralization. And if we did that, we were able to, with this protocol of decoupling for a certain amount of time, meaning staying thin in the bulk of composite, staying thin in the volume of composite for a certain amount of time, then we had the ability to flow or move all of the molecules towards the hybrid layer, so it did not stress the hybrid layer. This idea of immediate dentin sealing, which has become very common and very talked about in the world of biomimetic dentistry, was obviously first put into play in the world of adhesive dentistry. And we've talked about Sauteau's paper published in 1994 and Bertsinger's paper published in Europe in 1996. Pascal Magnier, 2005, gave us the actual numbers for immediate dentin sealing and how it quadrupled the potential bond strength if C factor was controlled and if surface preparation was controlled. And of course, we had to understand the bonding to carious surfaces. When I wrote the paper with Pascal, he was very excited that I had all of the numbers, scientific investigations on different surfaces, different C factors, and different preparations from the Japanese, and a key paper in 2003 from Van Meerbeek that showed that air abrasion was a surface conditioning to deal with the smear layer problem. My goodness, there's a lot to think about. But the bottom line is that this resin coating, once it was understood as an improvement over only immediate dentin sealing, and again, that came with the liner bond system of 1989, 1993 time period, then other companies started to make flowable composites. And the flowable composites had very vast differences in fillers. Some of the fillers were micron size, the micron versus the submicron filler particles. Every company had their own. Ours is the best, ours is the best. Of course, the only one that had been shown with published in vitro and in vivo research was the flowable composite came out of Japan. Everything else was just copying. And there were lawsuits in the United States because certain companies thought that they had invented flowables when in reality they had been invented in Japan. And so companies in the United States were suing each other for infringements of ideas that really weren't theirs. That's just how the world works. But once flowable composites became kind of, okay, that's the new thing. Yeah, this is good. Nobody understood how they were working or what they did, or if there was a difference between a flowable composite that was a chemical cure flowable composite or a light cure chemical composite, because the transition between light cured and chemical cure was happening just when flowables were coming into the national and international market. There's a huge difference between chemical cure and light cure in the rate of polymerization. 5 times, 500% faster with light cure. And of course, dentists aren't physicists. They're not, engineers. They kind of are simple-minded people thinking faster is better. So the light cure transition became hugely popular in the United States because it was faster. Fusiyama, in his 1980 book, was only using chemical cure adhesives, and these chemical cure adhesives had chemical cure composites put on top of them. It decreased the stress enough that they had long-term bondability in certain cavity preparations, basically class 1 cavity preparations. But then when the Americans started to go and the Europeans started to go on the flowable composites, the flowable composites were tested more systematically. And one of the most important papers was done by Didier Dici, and one of the graduate students at University of Geneva tested over 20 different flowable composites for modulus of elasticity, rate of polymerization, and bond strength to certain adhesives. It's very difficult to test all combinations of all adhesives with all flowables. But Dici was basically able to make a few assumptions, and those assumptions were if you get a higher modulus of elasticity, it was better. That's not so easy to do. The filler particles have to be in a resin matrix. The resin matrix interacts with the filler particles. If that happens well or doesn't happen well, it actually affects both the bond testing and the long-term success of a restoration if it's bonded internally to itself through the silicization of the ceramic particles to the resin matrix, or the polymerization of the resin matrix to the microfilled resin filler particles. Again, most dentists don't even want to think about this. But I was driven to figure this out because I was at my rope's end. A few years earlier, I quit dentistry out of frustration that these flowables that I used didn't change anything. I still had sensitivity. I still had teeth becoming root canals. I still had fractures in teeth. I was using adhesives. I was using composites. I was using flowable materials, but I didn't really understand the science that was involved. Once I had a ray of light, a ray of Ray Bertolotti's light shined on this problem, it inspired me to find another mentor. Gary Unterbrink inspired me to find another mentor. Didier Dici, in those years from 1995 to 2000, I understood that there is much science and that science needs to be integrated. It wasn't going to be one material is going to solve all your problems or one technique is going to solve all your problems. It had to be an integration based on understanding of polymerization dynamics of these composite materials. After we got that figured out, after testing it for 5 years in my office, I said, okay, I got this figured out. Now what are we going to do with it? We can keep being a dentist. That would have made us a lot more money. But the bottom line is that when I decided to start teaching, obviously I had to have dentists that could understand that resin coating is part of decoupling with time. In other words, the time it takes you to put resin at a 0.5 millimeter thickness on top of your dental bonding system, it's doing something very important. More than the importance of the flowable, it's allowing the polymerization of the dental bonding system to take place. It takes 1.5 minutes to put on your flowable and polymerize it. During that 1.5 minutes, good things are happening as far as the hemihydrogel formation in these 3 interdiffusionary zones of your hybrid layer. And so once that was firmly in my mind, and I started to teach that in 2003 to other dentists, then we came on the next breakthrough was what is the next layer on top of your resin coating? Again, it's going to be a resin, and how thick could it be, or what material would be ideal to still have the flow of the resin molecules as they polymerize into monomer, small polymers, larger polymers, that movement, as long as it's in one direction, then there's no stress that stretches the hybrid layer and can even debond the hybrid layer in the first few minutes of the restorative process. And so that hybrid layer, once we understood that resin coating was absolutely essential, the question is how thick? Because the thickness, we know if it got to 2 millimeters, then you'd have a 50% degradation of the hybrid layer. That exact number didn't come out until 2004, but I'd already figured that out independently based on the science. And so when the paper from Nicolanco was published in the first year that we were teaching the 6 lessons approach, I immediately put it into the articles that we had the doctors read. We started in 2003 with 20 articles, and then we went to 22, and then we went to 25, and then we went to 27. And at 27, I could see that, I probably couldn't help myself. Eventually, the doctors would have to learn 100 articles. But, for 99% of the dentists in the world, if we can just tell them what to do and how to do it, that's going to be enough. They don't need to know how to teach it. But when we started to teach the mastership program 5 years ago, I was kind of tired of just teaching the cookbook and knowing that many doctors would still have problems in difficult cases. And so I made a decision to start teaching these advanced concepts to dentists who were motivated to know more than just what to do. They wanted to know why it worked. And the resin coating worked because it was part of decoupling with time. The next layer, as long as it's thin, less than 1 millimeter, and of course, Simone Della Peri pioneered that in 2002, as long as that volume is in what we call micro C-factor increments, then there's no damage to the hybrid layer. How thick can you go? Well, you can go 1 millimeter thicker after the 0.5 millimeter that you've placed on your dental bonding system. So the Alleman Della Peri rule is don't get thicker than 1.5 millimeters of composite during the first 5 minutes of the polymerization reaction that was started with your polymerization of the resin of your dental bonding system. Okay, there's more. This resin coating in a vital tooth is critical to make sure that we don't have a transudation of fluid underneath the hybrid layer. Because when we get close to a pulp horn, particularly on a molar, then the pulpal fluid is being pumped every heartbeat into the bonding field. And if you take too much time to get the polymerization done, then you can have fluid, and that fluid gets bonded into the restoration as a sealed gap of fluid under the restoration that causes sensitivity. This can particularly happen when you're close to a pulp horn and you have a thin adhesive layer in your dental bonding system. dental bonding systems have adhesive layer anywhere from 10 microns to 80 microns. The thickest dental adhesives in dental bonding systems are Optibond FL, Allbond 3, and PQ1 from 3 different companies. The thinnest are almost universally manufactured because most early investigators were talking about bonding to enamel. And they wanted a strong bond to enamel, and they could get that with a very thin layer that wouldn't have the problem of pooling, which always increased the polymerization shrinkage. If you have too much of an unfilled adhesive, which are the thin adhesives, then that unfilled adhesive, if it pools, shrinks a lot, and that's where a gap will be more prone to form. And so the thin adhesives that are good on enamel are terrible on dentin because there is a transudation pumping against them. It thins that adhesive to even less than 10 microns. If you have an adhesive layer that is less than 10 microns, there is enough air in the ambient environment to inhibit the polymerization from the free radical initiator, which is called camphor-quinone. Camphor-quinone, when it hits oxygen, is unstable and it cannot then form free radical. Well, this oxygen inhibition was recognized for 100 years from people that worked with plastics all the time. And that oxygen inhibition layer, if you added some composite on top of it, wasn't a problem because the new layer of composite, when it polymerized, would diffuse free radicals and the free radical oligomers into that unpolymerized monomer layer, and they would polymerize from the top to the bottom rather than coming out of the layer that was polymerized underneath the oxygen inhibited layer. So this diffusion polymerization happened whether the oxygen inhibited layer was there or not there. Byung-Seo did some very good experimentations in the 90s on this. It showed that the oxygen inhibited layer didn't have anything to do with whether composites polymerized well with each other, but there was myths about that. And so you hear in dental students' vocabulary conversations all the time how you need an oxygen-inhibited layer to polymerize. It's just not true. That problem of transudation coming from the bottom and oxygen inhibition coming from the top means that if you get too thin, when you put the light on it, it doesn't polymerize at all. It's totally air inhibited. And so you think that you've got a layer of adhesive for your dental bonding system sealing the dental tubules, but the air inhibition in this situation completely means that it's not polymerized at all until the next layer is put on, which usually is a flowable composite now. But if you do not understand that this is a problem and that this is a problem, then you have that unpolymerized layer of your dental bonding system. Well, that problem can be solved by making the adhesive thicker. So the transudation can't poke little holes into 80 microns. It can only get up maybe 20 microns or 30 microns. So these thicker adhesive layers like Optibond FL, the FL stands for filled, and that filled means that it went from 10 microns to 80 microns. It was a very important improvement that Ao Kobashigawa made for Kerr Company. The only 3 real filled adhesives that overcome this idea of air inhibition and partially solve the problem of transudation. 2 of those have the problem of being one bottle systems, which we will talk about in another lecture. When we understand that we have this ability with the resin coating to make sure that adhesive layer polymerizes, even if it's been pounded with pulpal fluid coming out, this layer of resin coating is going to be 500 microns. You can't air inhibit 500 microns. There's only maybe 30 or 40 on top if you air thin a flowable. But if you air thin an adhesive layer of your dental bonding system, then you get to that 10 micron layer, which can mean that you won't get any polymerization with the light at the initial light curing stage. Okay, so, we've hit some pretty big ideas. Immediate dentin sealing should always be thought of in conjunction with resin coating. Some bonding systems have the ability to handle resin coating at the same time that they are forming the hybrid layer, but 2 of the 3 have a problem of the hybrid layer now becomes contaminated with solvents. And so these systems that are one bottle, universal systems that have one bottle, always have a contamination of solvents that interfere with a full polymerization of the monomers. And so you always will have a 30% reduction of your bond strength when you mix the priming elements that are hydrophilic with the bonding elements that are hydrophobic. So we do not recommend those, but it's always like, well, in my country, I can't get this, I can't get this. I understand. If you have to use a one bottle system, then what would you do? Not light cure it. You would add another layer of your one bottle system, another bottle layer of the adhesive, or another flowable immediately, and light cure those both at the same time. It's a technique that has been tried, and it does have some improvement, but the real answer to the problem is to find a 2-bottle system. If you have 2-bottle systems, that's your first indication that the manufacturer understands these problems of hydrophilicity, mixing with pulpal fluid, versus hydrophobicity, which is bonding with your restorative composites on top. And so those are the manufacturers that are, saying dentists are smart enough to understand this even at a basic level. So let's make products that they can get really excited about. Okay, well, that's our number 12. So we're very glad. I think that's going to finish our first season. So our first season of the 6 Lessons podcast is now in the can, as they say. Enjoy. Get bonded. Stay bonded.